as part of our digital electronics part of the course, we have been using microcontrollers, using Arduinos, which are, computers. And we there's this gap between the Arduinos and everything we've learned about flip-flops and digital logic and stuff like that. So I want to do my best to fill in that gap a little bit at least, and talk about a couple things that we've kind of skipped over. This will not be enough detail to do anything other than paint a picture for you guys. Okay, so first, we've talked about memory in terms of digital logic. So we can store a bit on a flip-flop or make a counter out of a bunch of flip-flops and keep a number there. And it's not hard to imagine having an array of those, but how do you, so you have 1,000 flip-flops, each with an on or an off. How do you navigate that without having 1,000 wires, connected to each one, and like what does that look like? Okay, so anyway, that brings us to what I want to talk about first. That is RAM, and in particular, this is like a RAM chip. So these are chips that you can buy that look like our other integrated circuit chips that we've used before. So RAM stands for Random Access Memory. The random here does not mean it doesn't mean it's giving you a random result or randomly accessing things. What it means is it's meant to contrast with things like tape drives, where on tape drives, your data is stored in a very, very particular order. Like you have these big wheels with magnetic tape on them, and you have to fast forward to the end to get the numbers over there and that sort of thing. Like accessing the numbers in order is much, much, much easier than accessing the numbers in any different order. Random here means that the data stored in the RAM can be accessed in any order, and it doesn't really matter. They're all kind of equally close by. The way that works, and we'll just do a little block diagram schematic of the chip to kind of explain this, our important inputs are labeled A0 through A14. This is a particular RAM chip we're looking at. This is called a 32K X8, which we'll explain in a second here. So A0 through A14 are our inputs, and D0 through D7 are our outputs. I should say these are actually inputs also. But anyway, so these over here are the address. So in other words, these are representing a binary number, and they are telling us what portion of the memory we are going to be currently requesting access to. And these outputs are where the data actually appears. So A is for address, D is for data. The 8 bits here at the output, so we have D0 through D7, that is 8 bits. 8 bits is also called 1 byte, B-Y-T-E. I forget if we've had to use that before or not, but so this is inputting or outputting 1 byte of data at a time, and that which byte we get is determined by which address location we are requesting. So there are other pins on this. Things like there's a pin that switches between reading and writing, so you can use these as inputs to store a value to a particular address, and other utility pins like that. But this is the important part. So what is going on with this 32K X8? So here, 32K is referring to the number of different addresses that we can have. So in fact, with 15 bits of input here, we can have 2 to the 15, 2 to the 15 different places to store data in. So that is this 32,000. So there are 32,000 different different locations in our memory. And each of those locations has 8 bits that it stores. So one byte of data, 8 bits of data. And yeah, so this is 32 kilobytes of memory stored on this chip. All right. So how would we use this? Well, we could, put in our address number here, maybe 000000001 or something, some number telling us where in the memory we're going to store this number. We do the other pin that says we're going to write this data, and we give whatever data we want to there. So we give it 10101010. It gets stored on flip-flops or something like that in the chip, and that will stay there as long as this chip still has power. More on that in a second. So then our circuit can go do other stuff. We can change the address, put some other data somewhere else, change the address, get some other data from somewhere else. And then we can put in that original address, 0000001, whatever I said. And with the pin set to read, it will give us output here equal to whatever number we stored originally. And this can do that at 32,000 different places. So that's pretty cool. 32 kilobytes of RAM is super, super duper small these days. I have an old computer that has 8 gigabytes of RAM, which means it has 8 billion different addresses for different bytes. This is, modern RAM is different than this because you can have, modern RAM has more data output pins, so each location in memory isn't just 1 byte. But anyway, this is getting too complicated. This at least gives you some idea of how RAM works and why the random. I mean, I still don't like the word random, but the idea that all these different locations are equally accessible, just because whatever number you put in here is the number, corresponds to the location you get the memory out, and you can switch between numbers here very quickly. You don't have to count up in order. All right. So like I said, if you disconnect power from the RAM, in general, you lose the information stored on it. That is not true. There are some non-volatile RAMs that exist, but in general, those are pretty rare. There are 2 kinds of volatile RAM. I should say 2 common kinds of RAM. SRAM and DRAM. So SRAM stands for static RAM, where the information is stored in little flip-flops, and DRAM, dynamic RAM, where the information is stored on little capacitors. Unfortunately, even though dynamic RAM sounds super cool, the information there on those capacitors disappears after a very short amount of time. I want to say like a millisecond without power. Just a millisecond even with power. And so as a result, dynamic RAM has to be constantly refreshed. It runs these cycles constantly to refill those capacitors as it goes. So anyway, if you're interested in dynamic versus static RAM, it's pretty interesting. Virtually, I don't know about everything. Personal computers these days all use dynamic RAM, DRAM exclusively. SRAM still exists in simpler, lower cost, lower computational power sorts of machines.